This video will be about logarithm properties. The first property we'll look at is the product property, and this says that the log base anything of a product is equal to the sum of their separate logs. So the log base a of n times n is equal to log base a of m plus log base a of n, where a is any number and n and m are both greater than 0. To see why this is true, we can look at properties of exponents. Recall from our exponents that when we had a to the power of n times a to the power of m, we could rewrite this as a to the power of n plus m. So this tells us that there's a relationship between the product of exponents and their sum. So if we want to see this with real numbers, we can have something like 5 to the power of 2 times 5 to the power of 3 was equal to 5 to the power of 5, or in logarithmic form, we would have log base 5 of 5 squared times 5 to the third is equal to log base 5 of 5 squared plus log base 5 of 5 cubed. Okay, so the quotient property is something very similar. It says that the log base a of m over n is equal to log base a of m minus log base a of n. And we can see that this makes sense because m over n can be rewritten as m times n to the power of -1. And then we can use our product rule that we just learned. Log base a of n to the power of -1. And then using the power product that I'll explain in more detail later, we can rewrite this part as a minus log base a of n. So an example of this, log base a 125 over 25 is equal to log base a 125 minus log base a of 25. Okay, so the power property that I was mentioning earlier says that the log base a of m to the power of n is equal to n times the log base a of m. Let's make sense of this by using our properties of exponents again. Let's just let x equal the log base a of m. So from this, we can write this in exponential form as a to the power of x equals m. Now, let's raise both sides to the power of n. So we get ax to the power of n equals m to the power of n, which can be simplified, the first part, to a to the power of xn is equal to m to the power of n. Now we can rewrite this equation in logarithmic form again. So back to logarithmic form, we have log base a m to the n equals xn. And now we can take our definition of x that we had earlier and plug it into this equation, so that what we end up with is log base a m to the n is equal to n times x, or n times log base a of m, which is what we were trying to prove in the first place. Another property that derives from these is the reciprocal property, which says that the log base a of b is equal to 1 over the log base b of a. So, for example, the log base 5 of 125 is equal to 1 over log base 125 of 5. And that makes sense because this number is equal to 3, whereas this number is equal to 1/3. They're saying that the two numbers are reciprocals of each other. Lastly, I'm going to talk about some logarithmic identities that should be fairly obvious or easy to understand. The log base a of a is equal to 1, because if we write that in exponential form, we have a to the power of 1 equals a. The log base a 1 of anything is equal to 0, because a to the power of 0 is equal to 1.